Okay, you're going to kind of start with the same thing, the 3x minus 2 for, let's say, your f of x and your g of x, let's say, will be x squared. Composition of functions means that you're substituting an entire function within or evaluating it inside of a separate function. So the way that composition of functions looks is f of g of x. Okay, now, on this one, you kind of need to recall what these function notations represent. Anything that you put in a parentheses on the function notation is going to be substituted in for every variable of that type, so every x variable in your expression. So f of g of x means we're going to take this function, 3 times the x is just a placeholder, minus 2, and we're going to put inside this placeholder whatever's in our parentheses. Well, here, instead of just a single number, we have an entire function. So what is the function g of x? So we're going to put x squared inside that placeholder. And so that would be your answer, would be 3x squared minus 2. Okay. If I said evaluate g of f of x, okay, you're going to take your g function, which is placeholder squared. Okay, and then what are we going to put in our placeholder? The whole f function, which is 3x minus 2. And so then we would expand this. If you guys recall the expansion rule for a binomial square, take the first term and square it. So square the 3, square the x. Okay, then take the product of those terms and double it. So 3x times a negative 2 is negative 6x. When you double negative 6x, you get negative 12x. And then square your last term. So negative 2 squared is a positive 4. And so here would be the value for g of f of x. What if I asked you to do g of x? What would that equal? So we take our g function, placeholder squared. Inside our placeholder, we're going to put x squared. And so x squared squared gives you x to the 4th. Perfect. When you take a power to a power, you add powers. And what if I, last one, gave you f of x? Three times some placeholder minus 2. What are we going to put inside the placeholder? 3x minus 2. And so when we simplify that out, 9x minus 6 minus another 2, and that simplifies to 9x minus 8. Huh? All right, I want to see, I'm going to give you a couple of those, and I want you to try to evaluate them. I want to go through and show you both the method for doing this by hand and then also the method by using your calculator. You can kind of choose whichever one you want to use. All right, so if we take our function, the first thing I'm going to do is I'm going to rewrite this so that there's no negative power. If I rewrite this with no negative power, this becomes 2 over x. And the reason I do that is now it winds up possibly being an easier problem to do by hand than to enter in your calculator. Because if I take my f function, which is 2 over some placeholder, what can I replace the placeholder with? The g function x minus 2, so there's my answer. Okay. If I take my g of f of x, I'm going to take my g function, which is a placeholder minus 2, and I'm going to put inside this placeholder 2 over x. And now, in order to solve this, I do need to simplify, rewrite this as a single fraction. What's my denominator going to be between these two terms? Again, this is like a 2 over 1. My LCD is an x. So I take my first term's numerator, 2, multiplied by any LCD factor missing from its denominator. Is this denominator missing the x? No, it has it there, right? So you just leave the 2 as it is, minus the next term's numerator, which is the negative 2, times what LCD factor is missing from its denominator? It's missing the x. So we're going to multiply that by x. And so this would be your form. And if you rewrote it with the x term written first, it would look like that. Okay, now, if you wrote this, or if you solve this with your calculator, it's going to show you this, but with the terms switched around, most likely. Olivia?
So explain again why there's a -2x.
Why there's a -2 here?
Yeah. Are you crossing?
Oh, when I rewrite this as a single fraction?
Yeah.
Okay, in order to do, so if you took 2 over x minus 2, and you want to combine them in the same fraction, you need to take your second term and write it with the same denominator. So I know I need to have an x in the denominator. In order to not change the value of that term, it's kind of like rationalize. You have to multiply by a number over itself, right? That's a value of 1. So 2 times x divided by x is equivalent to 2. So if you think in those terms, you can now combine this. The common denominator is x. The terms in the numerator are 2 minus the 2x. And so that's kind of how that came about. My shortcut for, like when I explain this, I don't go through this process the whole time. The way I do it is when you're combining your like terms, you figure out what is your LCD. I need an x and a 1. So I don't need to write it because it's just the 1. So I take my first term's numerator times any LCD factor missing from the denominator. It's not missing anything. It has the x. Then minus the next fraction's numerator times any missing LCD factor from its denominator. It's missing the x, so I have to multiply it by that. But the process is just this process. Were you able to follow that? We'll talk a little bit more about it as we go, if there's problems that kind of show up like that. Okay, let's talk about the calculator. If we use the calculator to solve this, you want to go to your y-editor. Whenever you embed a function within another function, so these composition of functions, you do want to use your y-editors. And just put the f of x in one of them. So I'm going to say 2x to the power of -1. There's my f function. My g function, x minus 2. So now, again, y1 of x, y2 of x. If you need to, write it down to make sure you know which one you're using for which, because you do need the order that you put them is going to play a role in what your answer is. So if I take f of g of x, I'm going to take my y1 of, replace g with the y2 of x. So that's, my composition should look almost identical. I'm just replacing the f with a y1 and the g with a y2. And when I hit enter, it confirms what I got here, 2 over x minus 2. And if I wanted my y2, my g function on the outside, and my f function on the inside, y2 of y1 of x, I'm going to just switch those terms around, hit enter. And again, it confirms here, it gives me the same thing, 2x minus 2. And